Hello everyone and welcome back to the video. In the previous lecture, I taught you about identities. In today's class, I'll teach you standard identities. So standard identity is something that you all should remember because it is applicable at many places in mathematics. So let's get started. The very first identity that I will teach you today is a plus b whole square. So what is a plus b whole square? A plus b whole square gives us a square plus 2ab plus b square. Now you'll say, why should I believe you? Let me prove and show it to you that how a plus b whole square gives us a square plus 2ab plus b square. So over here, a plus b whole square. What if I say 2 whole square? So you will write it as 2 multiplied with 2. So, in the similar manner, if I have a plus b of whole square, so it can also be written as a plus b multiplied with a plus b. Now, can you observe? This is a plus b. It's a binomial which is multiplied with another binomial. And you all know how to solve it. So, I'll write. Take the first term of the first binomial and multiply it with the entire second binomial. That is a multiplied with a plus b. And then I'll take the second term of the first binomial, that is plus of b, and multiply it with the entire second binomial, that is a plus b. Now, when I multiply a with the first term, that is a multiplied with a, then the second step is to multiply a with b. So I'll multiply a with b. Then what we have to do? We have to multiply b with a and then b with the second term, that is b. So I'll write plus b multiplied with a and then plus b multiplied with b. So over here we have a multiplied with a, which gives us a square. Here we have a multiplied with b, which gives us ab. And here we have b multiplied with a, which again gives us b. And here we have b multiplied with b, which gives us b square. Now, observe, aren't these two terms like terms? Because ab can also be written as ba, or we can say ba can also be written as ab. So, we have ab plus ab, which will give us 2 times ab. So, adding these two up, we get plus of 2 times ab. And the other two terms, that is a square and b square, will be written as it is. So I'll write a square and I'll write b square over here. That is a square plus twice ab plus b square. Wait, isn't it the same as this one? So now you'll believe me that a plus b whole square ultimately gives us a square plus twice ab plus of b square. So here we took the LHS and we made it equal to the RHS. I hope it's clear now. Now I'll teach you a very similar but a different identity, that is a minus b whole square. Previously I taught you a plus b whole square. The only difference is the sign that is in between a and b. So a minus b whole square gives us a square minus twice ab plus b square. So it is very easy to remember. The only difference is the difference of the sign of 2ab. In the previous one, we had plus 2ab. In this one, we'll have minus 2ab. So here, like there's a mistake in the PPT. Here it will be plus b square. We have a minus b whole square as a square minus twice ab plus of b square. So, should I prove it? Of course, I'll prove it for you. So, let us take the LHS. We have LHS as a minus of b whole square. Now we know that a minus b whole square can also be written as a minus b multiplied with a minus b. So this is multiplication of 2 binomial. Now what I have to do is, I'll take the first term of the first binomial and then multiply it with the entire second binomial. Now the second step is to take the second binomial, that is minus of b. And then I'll multiply it with the entire second binomial, that is a minus of b. Now, we have to multiply a with a and then a with minus b. So I'll write a multiplied with a and then I'll write plus of a multiplied with minus b. It's better to keep it in bracket. Now I'll multiply minus b with a. So I'll write minus of b multiplied with a. And then I'll write minus b multiplied with minus of b. Now, over here, a multiplied with a gives us a square. When a is multiplied with minus b, it will give us minus of ab. And when minus b is multiplied with a, it also gives us minus of ab. Because be it 2 into 3 or 3 into 2, the thing is same. It gives us 6. So be it a into b or b into a, it will give us ab. And the sign will be negative over here. Now over here, be careful. We have minus b and minus b. Minus into minus gives us a positive sign. And b multiplied by b gives us b square. Is there any like term? Yes, we have. We have minus ab and minus ab, which will give us minus of twice ab. So ultimately we have a square as the first term, minus of 2 times ab as the second term, and plus of b square as the third term. I think this is the RHS that we got. So yeah, this is the second identity that you have to memorize. The third identity that I'll be teaching you is an interesting one. And the identity is a plus b multiplied with a minus b gives us a square minus of b square. So let's prove it. Now I'll write the LHS thing, which is the multiplication of two binomial basically. We have a binomial that is a plus b, which is multiplied with another binomial that is a minus of b. Now let's prove it. What we have to do, we have to take the first term of the first binomial, multiply it with the second binomial, and then take the second term of the first binomial that is plus of b and multiply it with the second binomial that is a minus b. Now, what we have to do is, we have to multiply a with the first term that is a multiplied with a, and then we have to multiply a with the second term that is minus of b. Now, we have to multiply b with a initially, and then we have to multiply b with minus b. So I'll write plus of b times minus of b. Now, a multiplied by a gives us a square. A multiplied with minus b gives us minus of ab. B multiplied with a again gives us ba, or we can also call it as ab. But the sign will be positive, plus of ab. And plus into minus gives us a negative sign. B multiplied with b gives us b square. Now, just focus over here. We have plus ab and minus ab. So these two will cancel out. So the remaining thing we have is a square minus of b square, which is equal to RHS. Now, I'll be teaching you something different. I taught you the very first identity, that was a plus b whole square, which gives us a square plus 2ab plus b square. Now, let us check what will happen if I put minus b in place of b. Let us try what happens. So, the very first identity that I taught you was a plus b whole square gives us a square plus of 2 times of ab plus of b square. Now, instead of b, I have to put minus b. So, let us put minus b in place of b on the left hand side first and then on the right hand side. So, when I put it on the left hand side, what will I get? I'll get a plus of, in place of b, I'll put minus of b whole square. Now, here also, wherever we have b, we will put minus b. So, here we have a, so we'll write as it is, that is a square. Here we'll write 2 times a. Now, instead of b, I will write minus of b. Again, over here, I have b. Instead of b, I'll write minus of b and then put a whole square. Now, let us solve it. When I do a plus of minus b, ultimately we get a minus b. And we have a whole square over here. And over here, we'll write a square. Now, when 2a is multiplied with minus b, it gives us minus of 2 times ab. Now, when minus b is taken twice, that means minus b whole square, we get plus b square. Because minus b square means minus of b multiplied with minus of b, which ultimately gives us plus b square. Okay. Now, what is this? Is it looking something familiar? Yes. This is the identity 2 that I taught you. So what is the relationship between identity 1 and identity 2? When we put minus b in place of b in identity 1, then identity 1 becomes identity 2. That's it. Now let me teach you another identity, that is x plus a multiplied with x plus b gives us x square plus a plus b multiplied with x plus of ab. Let me prove it to you. So I'll take LHS, that is equal to x plus a multiplied with x plus b. So I think these two are two binomials and you all know how to multiply a binomial. So we'll take the first term of the first binomial and then multiply it with the entire second binomial, and then take the first binomial, that is the second term of the first binomial, and multiply the entire second binomial. Now, we'll multiply this x with each of these terms, that is x multiplied with x, and then x multiplied with b, and then a multiplied with x, and then we have a multiplied with b. When we multiply x with x, this gives us x square. When we multiply x with b, it gives us bx. When we multiply a with x, it gives us ax. And when we multiply a with b, it gives us ab. Now, just focus over here. In these two terms, do we have anything common? Yes, we have. We have x as a common term in both of these terms. So what we will do? We will take out x. So I'll write x square as it is, and from these two terms I'll take x common. After doing so, I'll get a left from this term and b left from this term. Here we have plus a and here we have plus of b. I did nothing. I just took out x common from both of these terms. So x is common. I get a for this term and I get plus b for this term. And this ab will be written as it is, which is equal to RHS. So this was another identity that you learned today. Now I taught you one thing, that whatever value of variable we put in an identity, LHS is always equal to RHS. Just few minutes back I taught you an identity. What was that? It was x plus a. When it is multiplied with x plus b, it ultimately gives us x square plus a plus b of x plus of ab. Now, let us put a is equal to 2, b is equal to 3 and x is equal to 5 in this identity, and let us check that is LHS coming equal to RHS or not. So, I'll take LHS and put the following values. Now, the value of x that I have to put is 5, a is 2 and b is 3. So, I'll put x is equal to 5 plus the value of a is 2. Again, the value of x over here is 5 and the value of b is 3. 5 plus 2 gives us 7 and here we have to multiply with this with 5 plus 3 which gives us 8. Now 7 into 8 gives us 56. Now let us check for RHS. For RHS what we have is, we have x square. So in place of x I am putting 5. So I will take 5 square plus, I have a plus b, that is 2 plus 3. Now in place of x I have to put 5 plus of a into b, that means 2 into 3. Now when I do 5 square it gives me 25. When I take these two sum, that is 3 plus 2, this gives me 5 and 5 multiplied by 5 gives me 25. Now I have over here is 3 into 2 which gives me 6. 25 plus 25 gives me 50 plus 6 gives me 56. So LHS is coming to RHS. So we can write LHS is equal to RHS and hence it is verified. So we have now just verified the identity 4 by putting values a is equal to 2, b is equal to 3 and x is equal to 5. Now again just recall the identity 4 that I taught you. That was x plus a plus x plus b is equal to x square plus a plus b into x plus of ab. Now what happens if I take a plus b, let's say equals to a. That means I'll write a as a and b also as a. Now let us see what happens. So I'll write x plus a in place of a, but in place of b again I'll write a. So I'll write x plus a. Over here I'll write x square. Now I write a in place of a, but in place of b I'll put a again because a is equal to b. So I wrote, I'll be writing a over here again, and then I'll write x. And again in place of b I will write a. So it is a multiplied with a. So finally what do I get? X plus a into x plus a. 2 multiplied by 2 gives us 2 square. So x plus a multiplied with itself gives us x plus a whole square is equal to x square, that is x square. Now a plus a gives us twice a. So we have over here twice a and we have x over here. So we'll get twice ax because a plus a gives us 2a and 2a into x gives us 2ax. And over here we have a into a, that is a square. Now, isn't it similar to identity 1 that I taught you? A plus b whole square gives us a square plus twice ab plus b square. If we consider x as a and a as b, then isn't the identity looking same as identity 1? A plus b whole square is equal to a square plus twice a into b plus b square? Yes, it is. So, we can say that identity 4 is a special case of identity 1. When we put a is equal to b in identity 4, then it gives us identity 1. Now, we will consider another case of identity 4. This is a special case. So, in this case, what we will do is, we will put a is equal to minus of c and b is equal to minus c in identity 4. Let's put it and see what happens. So, I'll put a is equal to minus c and b is equal to minus c. So, that means I am putting the same value for both the variable a and b, that is minus of c. So, I'll write x as it is. In case of a, in this place I have to write minus c. So, I'll write x minus of c. Again in place of b I have to write minus c. So, I'll write x minus of c is equal to. In case of x I have to write x only. So, this will be as it is, that is x square. Over here we have to make some changes. In place of a I'll write minus c. In place of b again I'll write minus c. And over here I'll write x. Now, just look at over here. In place of b square, in this identity we have a multiplied with b. That is x plus a, x plus b gives us x square plus a plus b into x plus of ab. This was identity 4. So in this place ab we have to put minus c and minus c. So we'll put minus c multiplied with minus of c. Now over here x minus c and x minus c gives us x minus c whole square. X square gives us x square as it is. Minus c gives us minus 2c. When it is multiplied with x, it will give us minus 2cx. And over here, minus c into minus c gives us plus c square. So this will be plus c square. Now, is this identity related to some other identity that we have learned earlier? Yes, it is. It is related to the identity 2 that we learned earlier. That was a minus b whole square gives us a square minus of 2ab plus of b square. Don't you think this identity, that is a special case of identity 4, looks like identity 2? Yes, it is. So, if we put a is equal to minus c and b is equal to minus c in place of identity 4, we will get a special case, that is identity 2. Now let us take another special case of identity 4. In this case, what we will do is, we will keep a as it is and we will change b. We will write minus a in place of b. Let's do and check what happens. So I'll keep x as it is and a as it is in identity 4 and I'll change b. That is x. Instead of b, I have to write minus of a. So I wrote minus a over here. Now, in place of x, I have to write x only. No changes over here. And in place of b, I have to write minus of a. And over here, I'll write x. Again, in place of a, I'll write a. which should be multiplied with, in place of b I have to write minus of a. Now x plus a into x minus a, this is what we have on the left hand side. So we'll keep this as it is, that is x plus a into x minus of a. Now over here what we have is x squared. Now we know that a minus a gives us 0, and 0 multiplied by x will ultimately give us 0. Now here we have plus into minus, that will give us minus of a square. So we'll write minus of a square. So ultimately what we have is x plus a multiplied with x minus a gives us x square, and over here we have minus a square. So I'll write minus a square. Now, was there any identity that I taught you which is similar to this identity? Yes, identity number 3. That was a plus b, when it is multiplied with a minus b, then it ultimately gives us a square minus of b square. So from here I can say that when in identity 4 I put b is equal to minus a, then we get a special case which is related to the identity 3 that I taught you earlier, that is a plus b into a minus b gives us a square minus of b square. Now that we have learned the identity, let us solve few questions based on identities. So the very first question that I have over here is 2x plus of 3y whole square. So the identity that we'll be using over here is a plus b whole square. In order to avoid confusion, let me write it over here. Just consider a as 2x and just consider b as 3y. And the identity that we'll be using is a plus b whole square, which gives us a square plus 2 times of ab plus of b square. Now using this identity in this question, what do we get? So we have considered 2x as a. So we have to take first a square. So I'll take 2x whole square. Next we have 2 times a into b. So I'll write plus of 2 times a is 2x. And in place of b what we have? We have 3y. So we'll write 3y. Now the third thing we have is plus b square. So I'll write plus, instead of b square here we'll write 3y whole square. Because here in place of b we have 3y. What I'm doing is just comparing this identity with the standard identity. And using it, I'm solving it. So when I have 2x whole square, this means 2x multiplied with 2x, which gives us 4x square. So I get 4 times x square plus. Now over here I have 2 multiplied with 2 multiplied with 3. So 2 multiplied with 2 gives us 4 and 4 multiplied with 3 gives us 12. X multiplied with y gives me xy. And when I multiply 3y with 3y, because we have 3y whole square over here. So 3y into 3y gives us 9y square. So ultimately, this is the answer that we have solved, and we have used the identity a plus b whole square over here. Now let us solve another question using identity, and the question over here we have is 103 whole square. Now you might be wondering that we can calculate 103 whole square by simply multiplying 103 into 103. But I have an easier and quicker method to do it by using identity. Can I not write 103 as 100 plus 3 and then I'll take the whole square? So again, here, just think 100 as a and 3 as b. So isn't it the identity a plus b whole square? And we know that a plus b whole square gives us a square plus twice ab plus of b square. Now, let us solve it using the identity. So, in place of a, we have 100. So, the first thing we have is 100. Sorry, we have 100. So, we'll take 100 square plus 2 times a into b. A we have 100. So, I'll write 100 into 3. Because b we have 3, and then we have plus b square. So I'll write plus, instead of b we have 3 over here. So I'll take 3 square. Now 100 square gives us 10,000. plus 2 into 100 into 3. What will it give? 3 into 2 gives 6 and 6 into 100 gives us 600. Over here we have 3 square which gives us 9. So ultimately the answer that we'll get is 10609. So this is the final answer of 103 whole square using identity. Now we will be using identity 2 to solve these two questions. So let me write identity 2 first over here so that you all can recap it. The identity 2 that I taught you was a minus b whole square, which is a square minus of twice ab plus of b square. So the very first question that we have over here is 4p minus 3q whole square. So just consider 2p as a and 3q as b in your memory and try relating it with the standard identity that we have. So the first thing we have to write is a square. That means a over here is 4p. So we'll take 4p whole square. Then we have minus of 2 times a into b. A is 4p and b is 3 times of q. Again we have plus b square. So for plus b square I'll write plus, and for b we have 3q. So I'll take 3q whole square. Now when we take 4p whole square, that means 4p multiplied with 4p, which gives us 16p square. Now over here we have 4 into 2 into 3, which gives us 4 into 2 is 8. 8 into 3 is 24. We have a minus sign over here, so we'll have minus 24, and p into q gives us pq. Over here we have 3q whole square, which will ultimately gives us 9q square. So we have plus 9q square. So this is the ultimate answer of the question 1 using the second identity that I taught you. Now we'll solve another question using the second identity, and the question we have over here is 4.9 whole square. Again, I'll be giving you an easier method to calculate this using identity. So 4.9 can also be written as 5 minus 0.1, and we'll take the whole square. So now we can use the identity a minus b whole square. We will consider 5 as a and 0.1 as b in our own memory. And now we will just use the identity 2. So we'll take a square, that is 5 whole square. And then using the identity we have minus 2 times ab. So I'll write minus 2 times a is 5 and b is 0.1. And then we have plus of b square, that is plus of 0.1 whole square. Now 5 square gives us 25 minus of 2 into 5 into 0.1. Ultimately the sign will be negative. Here we have 2 into 5, which gives us 10. 10 multiplied with 0.1 gives us 1. Over here we have 0.1 whole square, which means 0.1 multiplied with 0.1, which ultimately gives us 0.01. So here I am writing plus of 0.01. According to the BODMAS rule, I'll add 25 with 0.01 first. So I'll write 25.01 and then subtract minus 1. So ultimately my answer will be 24.01. I hope it's clear to you now. Now that I have taught you so many identities, let's learn some more application of those identities. Over here, we'll be using the identity 3 that I taught you. So let me write what was identity 3 so that we can all recap it. Identity 3 was a square minus b square. This was the right hand side. What was the left hand side? It was a plus b into a minus of b. That means that a plus b when multiplied with a minus b gave us a square minus b square. Over here in question number 1 we have some misprinting. So let me write the question to you. The question basically is 3 by 2m plus of 2 by 3 times of n, and this is again multiplied with 3 by 2m minus of 2 by 3n. Now just compare this with the identity 3. Can't you see that this is a, like just consider it as a and consider this as b. Again this 3 by 2m, so we have taken 3 by 2m as a. So this is a and again this is b. So what is it? It is A plus B multiplied with A minus B. So we can use this identity. That will be equal to A square minus of B square. So let us use it. Ultimately, A plus B and A minus B will give us A square minus of B square. So I'll take A, that is 3 by 2m, and I'll take the whole square of this thing, subtracted by B square. B is 2 by 3n. I'll take the whole square of this. 3 by 2m whole square gives us 9m square by 4, and 2 by 3n square gives us 4n square by 9, and there is a minus sign in between. So this will be our final answer for question number 1. Now let us solve the second question that we have over here. That is 983 whole square minus 983 whole square. Just take identity 3 in the reverse way. We have A square minus B square. Consider 983 as A and 17 as B. Isn't it A square minus B square? So A square minus B square gives us A plus B into A minus B. So we'll take A, that is 983, plus B, that is 17, and it will be multiplied with A minus B, that is 983 minus of 17. Because A square minus B square gives us A plus B multiplied with A minus B. When we do 983 plus 17, this gives us 1000. And it should be multiplied with 983 minus 17, which gives us 966. So ultimately our answer will be 966000. Using the same identity, we will solve the third question, that is 194 multiplied with 206. So here we can write 194 as 200 minus 6, and then 206 can be written as 200 plus of 6. Now here we can use the same identity, that is identity number 3. Here we have 200 minus 6 and 200 plus 6. So A plus B and A minus B. If we consider 200 as A and 6 as B, so this is A plus B multiplied with A minus B. And we know this ultimately gives us A square minus B square. So A square is 200 whole square minus B square is 6 whole square. 200 whole square gives us 40,000 minus 6 whole square gives us 36. So 40,000 minus 36 will ultimately give us 39964. So this is our final answer of the given question. Now we will solve some examples on the fourth identity that I taught you. And the identity was x plus a multiplied with x plus b gives us x square plus a plus b into x plus of a into b. So the very first question that we have is 501 into 502. So over here, 501 can also be written as 500 plus 1, and it is multiplied with 500 plus 2. The very first step is to compare it with the standard identity. So here we can see that 500 can be written as x, 1 is a. Again we have 500, it is the same thing, so we'll write x. And we have 2 over here, so it can be written as b. So ultimately, this is the same identity, x plus of a and x plus of b, which is multiplied. So we will use this identity and solve the question. X plus a and x plus b gives us x square plus a plus b x and plus ab. So I'll write x square first. X is 500, so I'll write x square, that is 500 whole square, plus of a plus b into x. A is 1. Again, b is 2. Again, it will be multiplied with x, that is 100. And then we have a into b, that is 1 into 2, which gives us 2. So here, 500 square will give us 250,000. Here we have 2 plus 1, 3. 3 multiplied by 500 will give us 1500. And here we have 2. So ultimately, when we add all of them, we get 251,502. So this will be the final answer of the given question using the fourth identity that we learned earlier. Now using the same identity, we will solve another question. This is a bit different, but the same identity will be used over here. So here we have 95 into 100. 95 can also be written as 100 minus of 5. And 103 can be written as 100 plus of 3. Over here, we have to make a small change. That is, we have to write 100 minus 5 as 100 plus of minus 5. And then we'll be writing 100 plus 3 as it is, 100 plus of 3. So, compare this identity with the standard identity that I taught you. So, when we compare it, we get that 100 is x, then minus 5 is a, again 100 is x, and 3 is b. So, it is an identity that I taught you earlier. X plus a multiplied by x plus b. So, we will use the right hand side to solve this given question. So, x plus a into x plus b gives us x square plus a plus b x plus of ab. So, I'll write x square, that is 100 whole square, plus of a plus b. Over here, a is minus 5. So, I'll write minus 5 plus b. B is plus 3. So, I'll write minus 5 plus 3, which is multiplied with x. So, I'll write 100 in place of x. Now, we have plus of a into b. A is minus 5 and b is 3. So, I have minus 5 multiplied with 3. So, ultimately, 100 square gives us 10,000. Now, we have minus 5 plus 3, which gives us minus 2. Minus 2 into 100 gives us minus of 200. And over here, minus 5 into 3 gives us minus of 15. So, we will get 10,000 minus of 200, and minus 15 gives us minus of 215. And when we subtract 215 from 10,000, ultimately we get 9785. So this is our final answer. Hope you all enjoyed the learning.